All right, AP Psych. This is our last section of the brain, the cerebral cortex. What you see in front of you are three quick kind of warm up reminder questions from the limbic system. So if you want to try to answer them real quick, you want to pause it now because I'm going to start going over. So, according to neuroscience, why are children and young teens more emotionally unstable than adults? Because of the lack of myelin sheath in the frontal lobes, frontal cortex, which causes the amygdala to process info. And since it's the amygdala, usually feelings of fear and anger are the result. So that's usually why teens and children tend to fly off the handle, get angry at small changes. And that's because the amygdala is working faster than the frontal cortex, frontal lobe. Which part of the limbic system is responsible for processing long-term memories? Your hippocampus. And which part of the limbic system is called the pleasure center, controls our eating, drinking, and temperature controls? That's going to be the hypothalamus. So the main thing we're looking at today, cerebral cortex and aphasia. This part of the brain is going to be divided up into different lobes with different parts, and then the aphasia we'll actually look at as misuse of language. So when we look at the cerebral cortex, it's going to be this wrinkly covering. All those wrinkles are really just major neural networks that have shown. So as your brain develops, it will get more wrinkly. It's not flat and smooth when you're born, but as you gain more experience and live longer, you're going to develop more of these deep fissure wrinkles. So the neural networks combine to create the body's control and processing center. So everything we process, everything we can control is going to be from this section of the brain. The majority of it is going to be made up of the association areas. And these are just the non-committal. So they're not involved in speaking, they're not involved in controlling your motor functions, and they're not involved in the sensory interpretation. So like the motor cortex, which would be right here, the sensory cortex, which would be right here, Broca's area, Wernicke's area, the visual processing center, the angular gyrus, and the auditory cortex. Those are the only non-association areas in the cerebral cortex. We think they're involved in thinking, learning, speaking, remembering. They have to be involved in that in some way, shape, or form. That's why we can explain all the complex thoughts, the complex behaviors, the complex emotions that we feel. And so the cerebral cortex is divided into two hemispheres and four lobes. So technically you have like two parietal lobes, two occipital lobes, two temporal lobes, and two frontal lobes. So here's a better kind of picture of the association areas. They would be in pink here. And then you would have like your Wernicke's area right there. Your angular gyrus will be right about here. So this is where we kind of get those myths, or that myth that you only use 10% of your brain, because a lot of the cerebral cortex is uncommitted. And how we know this is uncommitted areas, during brain surgery, these would be electrically stimulated to see if anything happened over the years, and nothing was happening. Patients did report in certain areas feeling, thinking, and remembering certain things though too. So that's where we get that idea. So the hemispheres of your brain, you have your left hemisphere. This is your logic, L for logic. So math, chemistry classes, a lot of your science classes, a lot of the things where we necessarily don't need a lot of imagination to learn, those are going to be linked here. Happiness does result in the left hemisphere. So truly the people who, accountants, things like that, are usually thought to be as happier people than more of your creative people. Right hemisphere, this is controlling your creativity, imagination, perception, and facial recognition. So our creative writing, Miss Matoka's classes, any drama classes, those are going to be a little highly more enjoyable. Depression is usually going to be the result of overactive right hemisphere. So if you're really an imaginative person, you're going to use this side of the brain more often than, say, your average person. So depression is going to be the result of overuse. Now, one thing about these hemispheres, a lot of people like to say they're left or right hemisphere dominant. the most artistic person in the world is still left hemisphere dominant. And the main reason they're still left hemisphere dominant is because we all use language to communicate. So while an imaginative person may think they're right side dominant, they're going to more likely have an overactive right hemisphere, not a dominant right hemisphere. So we're all left hemisphere because of that language. We use it to communicate, we use it to learn. Some of us may have more activity or more neural connections in the right hemisphere that make us more creative. Frontal lobe, it's going to be located just behind your forehead. This is going to be involved in speaking, muscle movements, judgments, plans, personality. And the specific parts, the first is the prefrontal cortex. This is the executive of the brain. This is going to process your risks, your goals, maintains your emotional control, and also contains your moral compass. So like teenagers, this is where the myelin sheath is starting to develop for you. Like if you have noticed that you have a better ability to plan out your day and plan out your week, you're seeing more myelin sheath develop in the frontal cortex. If we damage it, personality change, moral decay, and lack of emotional control can be the result. So you can actually have personality change. Think of Phineas Gage from your reading. The motor cortex, this is going to be at the very back of the frontal lobe, and this is going to control our muscle movements. If you look at the picture over here, this is your motor cortex. So each section of this cortex is dedicated to a specific part of the body. And the bigger the part, the more motor movement it has. Damage to the motor cortex can result in muscle lack or loss of muscle movement, depending on how much damage is done. And then the Broca's area, this is going to be directly connected to the motor cortex, but this is going to help produce and control your voice box to produce speech. So the Broca's area and the motor cortex are going to work together to produce speech. And damage to the Broca's area will result in what we call Broca's aphasia. Aphasia is just a fancy term for a misuse of language, and this is going to be difficult to initiate speech or labored speech. A person with a stuttering problem could have Broca's areas problems, but usually the only time we experience like Broca's aphasia is due to a stroke that attacks that specific part of the brain. We can still understand that speech, but it's difficult in speaking. So like it may take me a minute to answer one of your questions. If I had Broca's aphasia, it would take me 3 to 4 minutes, but you would still understand it. So temporal lobes, these are located right on the side, right next to your ears. And they're going to process sound sensed by your ears. Opposite side processes your opposite ear. So left ear is processed by the right brain. Right ear is processed by the left brain. Opposites. This is where auditory cortex is located. And the main part here is going to be the Wernicke's area. And Wernicke is going to help you the syntax and the grammar of your speech. So if, for example, we damage the Wernicke's area, your speech would be jumbled. It wouldn't be necessarily difficult to initiate, but you wouldn't be able to understand it. And so when we look at Broca's versus Wernicke's aphasia, I'll post those links to the folder just underneath this. It's good to watch just to show you the difference between the two. Parietal lobes, these are going to be kind of located at the top, kind of back of your head. Always kind of think where the soft spot on the skull for the children are. This is where the parietal lobe is. So this is really just going to interpret your sensation of touch. It has the somatosensory cortex, formerly the sensory cortex, and this is going to interpret all the sensory information sent from these parts of the body. Damage to it could result in a lack of feeling or a lack of interpretation of that signal. So when you look at this guy, he is disproportionately made due to the extent or the area occupied by that part. So our face, our hands are very sensitive, so they have a bigger part of the sensory cortex. That's what that's kind of showing you there. The angular gyrus is the second part, and this is just going to transform your visual code into auditory code. So that voice you hear when you read to yourself, that's your angular gyrus. It's not your conscious, it's just your angular gyrus. It's helping you read this to yourself. Because if you didn't have this, you would have to read everything out loud for it to be processed. Occipital lobe is going to be our last lobe of the brain. It's located at the back of the head. Deals with vision, and is going to contain our visual cortex. So that's also, if you've ever been hit in the back of the head, your vision may be blurry, or you may even black out for a second, and that's because that signal being sent from the eyes to the brain has been disrupted. And obviously, left eye goes to right brain, right eye goes to left brain. That's how everything really works in the brain itself. And that's really it where you have it. Frontal lobe and your parietal lobe are probably looked at as a little more important because they have more functions, more parts, but they all work together to make us think, feel, and react.